Okay, we're going to continue to review for the Unit 3 exam. And so in our previous segment, we did lesson number 15, and now we want to do lesson number 16, which is going to be on properties of stars. So in your textbook, you should be reading chapter 12, and you should also go back to some previous lessons that we've done. So lesson number 5, section number 4, review what Kepler's third law is. Okay, then from lesson number 5, go to section 5 and review what center of mass is. And then from lesson number 6, section number 3, review what a black body is and the black body radiation laws. And then from lesson number 7, section 10, review what spectroscopy was. So you might want to review those lessons before you take the exam. So you need to know what an arc second is, so that if you go around in a complete circle, that's going to be 360 degrees. Or another way of saying that is 360 arc degrees. Now, if you take 1 degree and you chop it up into 60 pieces, then that is going to be called an arc minute. So that there are 60 arc minutes inside of 1 degree. And then if you were to take one of these things and chop it up into 60 pieces, then those are going to be called arc seconds. And so there are going to be 60 arc seconds, double tick mark, is going to be equal to 1 arc minute. So the main thing is know what an arc second is and how to recognize it with the double tick mark, because that's going to be the unit that is going to go into this formula. So you should know what parallax is. So the idea of when you take your finger and you put it in front of your face and then you go from one eye to the other eye and you see that your finger jumps back and forth. So that's going to be called parallax. And so we're going to look at stars that jump back and forth depending on how far away they are. And so an astronomer is going to measure the angle, the parallax angle that the star makes in the night sky, and then they're going to put that into that formula. So that formula is that the distance to the star, r, is equal to 1 over its parallax angle. Now the unit for the distance is going to be the parsec. So that's the official metric unit that comes out of the formula. And then the unit that goes into it is going to be the arc second. So you should be able to do a problem like this. If I give you the distance to the star, you should be able to calculate the angle. If I give you the angle, you should be able to calculate the distance. And remember, they're always flip-flopped. So it's always 1 divided by the angle gives you the distance, or 1 divided by the distance gives you the angle. So you're doing 1 divided by that number. So it's a very simple formula, and then that tells you the distance to a star. Okay, the next thing is how do we figure out the apparent brightness of the star, or how do we figure out the real brightness of the star? So the real brightness is going to be L, the luminosity. That's the real brightness. It never changes. So every star has a certain real brightness. Now the F, on the other hand, changes. So this is the apparent brightness. And so that one does change. So something is very bright if it's close to you, and it looks dimmer the further away it gets. So that's the F. The R is going to be the distance away from you. So we normally measure this. We measure the apparent brightness with a photometer. A photometer is a device that measures the apparent brightness of light. We then can calculate the distance to the star, the letter R, by using this technique up here. Then we can take those two numbers, plug it into that formula, and then solve it for the letter L. Now, what are you going to do on the exam, though? So, I would want you to be able to do something like this. If a light bulb gets 8 times further away, what happens to its luminosity and what happens to its apparent brightness? So, all you got to remember is it's 1 over r squared. So that you're going to take the 8 and you got to square it. So 8 times 8 is 64. So it's going to be 64 times dimmer. Or you could say it's 1/64 as bright as it once was. So don't worry about that 4 pi thing in there. So the reason for the 4 pi is because that is in the equation for the surface area of a bulb. So the area of a bulb is 4 pi r squared. But you don't need to know that in order to do one of these kinds of problems. Now I do include, there's one where you put real numbers into the equation and then you solve it for, let's say, the actual brightness of the star. But you're not going to be doing that on the exam. Okay, let's take a break, and when we come back, let's talk about how we measure the mass of a star.